Okay, the final part of this problem, part C, says, let Y be the depth in inches of the coffee in the cylindrical coffee pot. Now, the new question is, at what rate is Y changing when H is 2? So, we would, at first glance, think that we need, in step 2 of the process, to write a single equation that relates Y to H. So that means, up in this picture, we would want an equation that relates the depth of this coffee to the height of this coffee. Now, I don't know about you, but that looks a little hard. So instead, we can use something that we also know here. We just, in part B, figured out dV dt for the volume of the coffee coming out of the cone. Well, that volume of coffee coming out of the conical filter is the same as the rate at which coffee is coming into that pot on the bottom. So in part C, we actually know dH dt, of course, is still going to be that h minus 6, but we also know dV dt at this time for the cylinder is going to be the opposite of this rate, because the coffee in the cone is decreasing while the coffee in the pot is increasing. So we can write that the volume's rate for the cylindrical container will be a positive 4 pi inches cubed per minute. So that means now we can just relate the volume of the cylinder to the depth of the cylinder, and that's going to be a lot easier. We knew up here that the volume of a cylinder is pi r squared times y. So down at the bottom, I could write the volume of the cylinder is pi r squared times y. Now, at first glance, this looks like we have the volume in terms of r and y, and we don't know what the rate of r is. But if we go back up, they tell us that the base of that coffee pot has an area of 9 pi. So they're actually telling us what this pi r squared is. So that volume is really a 9 pi times a y. So we can use that down here and write the volume of the cylinder is a 9 pi times y. So now we're ready to take the derivative, because we have the thing that we know in terms of the thing that we want, which is dy dt. So if I take the derivative of both with respect to time, I'll move through the constant and hit the y. So that was step 1 here, was going back to our picture, figuring out what we know, what we want. Step 2 was connecting them. Step 3 is taking the derivative. So now step 4 and 5, we want the instant in time. Well, at the instant in time, we know that 4 pi is going to be our dV dt. So our job is to isolate dy dt. So if I isolate dy dt, we will get a 4 over 9. And now we need to interpret. We're talking about the depth of the coffee. So we're measuring that depth in inches. So we would write, at the instant in question, the depth of coffee, in the pot is increasing. Notice that's a positive number. So we're increasing at a rate of 4/9 inches per minute. And we're done.